There we go. Hello, everyone. Good to be here. And yeah, great to see so many students here, actually. It's very humbling to see those familiar faces. By the way, everything that I'm saying today is relevant for the exam, so please take notes. Now, question to the crowd. Who loves champagne? Who drinks champagne on a regular basis, apart from the EV vehicle owners? Yeah, me too. I love champagne. Like actually, when I started studying and diving into viticulture and winemaking, one thing that fascinated me about sparkling wine is that there's so much of mysterious things going on in terms of wine chemistry that's happening in a bottle that we still, from the science perspective, still don't know what's happening, but it just tastes amazing. And there's a huge, beautiful, chaotic history behind it. And yeah, I thought it would be a good occasion to share that with you. So to give you a bit of an idea what Champagne actually is. Champagne is a region in France. It's one of the most northern winemaking regions in France. And it produces 99% sparkling wine. So pretty much no still wine, no Chardonnay still, no red wines that are still, etc. Everything is bubblies. And they're doing it in a very amazing protective way. So if you produce sparkling wine here in New Zealand, wanted to call it champagne, you would be sued within a minute. So they're very protective of what they're doing, but that's why they're so expensive, so exclusive, but also for a reason, because they do taste a bit different than other sparkling wines around in the world. But historically, that was not always the case. Pretty much all the way up to the 17th, 18th century, Champagne produced still wines like everyone else. And they were actually in competition with Burgundy, wines from Burgundy. And they had a really good case because it was a bit cheaper and easier to transport the wines from Champagne to Paris, where all the rich people were drinking it. So they had a good advantage there. But then something happened, which was the small ice age. And things became a little bit complicated for Champagne. So starting from the 14th century on, temperatures in Europe were plummeting. And as the Ice Age was moving on, large water bodies all around Europe were just freezing during winter even. So the River Seine in Paris was regularly frozen. People would ice skate over it. The lagoon in Venice would be frozen as well, even into the 18th century. So it was bloody cold. All right. Now, this also meant that agriculture had problems and viticulture had problems. Grape growing had problems, right? And one aspect that brought actually problems is a bittersweet tragedy for the Champagne region. So what would actually happen normally before the Ice Age? Champagne is already quite a northern wine region, so it's fairly cold compared to other regions in France. So once the grapes are harvested, the fermentation starts. Usually you would hope that the fermentation continues all the way to dryness, and then the wine would be bottled, sold everywhere. Pretty much the same process as today. What happened though with the Ice Age is that in an already cool wine region, the Ice Age actually shortened the period of summer and autumn. And because of those cold temperatures, the fermentations in the cellar would actually stop before all the sugar was consumed by the yeast. The yeast was like, it's too cold, I'm going home. F this, right? And people couldn't really make sense out of it. They're like, okay, the wine is done, let's bottle it, or transport it to Paris, where they would be stored and obviously not drank all directly. And people that had those wines and would open them in April, May, June, so when the temperatures were rising again, were actually observing that the wine was bubbly, fizzy. The fermentation has actually restarted again because some yeast survived. There was still sugar in it, right? The main problem is, though, that the French aristocracy didn't like that. They thought like, I don't want these bubbles. It's poor winemaking. I want my still wine, right? So they rejected this. And this problem became so severe that the Catholic Church actually stepped in and said like, we need to do something about it. We know that we have this one really intelligent, great monk called Dom Perignon. You might have heard of him. Can you help us to do something about it? Can you reverse it? Can you get the bubbles out of that nasty wine so that we can actually continue selling it to Paris? And he said, yep, I do this. I'll endeavor on doing it. And that's what he started in, I forgot getting the dates right, beginning of 1660s. What he didn't know, at the same time, and even a few years before, somewhere else in Europe, there were actually some people that liked those bubbles. And that's King Charles II in Great Britain, so in England back then. There, the high society actually adored those little bubbles. And I will come back to that a little bit later. So the years were going by, and Dom Perignon was working in his abbey on methods to actually try to get rid of those bubbles with little success, actually. And we're talking about a few years, 4, 5, 6 years. During this time, the French aristocracy, so in the royal court of Versailles, around Louis XIV, started to fancy sparkling wine. So they actually went to Dom Perignon and said, like, look, you know what we told you like 5, 6 years ago? Can you just do the opposite? We want more of this bubbly, fizzy, beautiful drink. And it's like, okay, actually I like that more because this other was just a pain in the ass. It didn't work anyway. And so he continued doing the opposite, actually, and he started to optimize the process of sparkling wine production. Here you see him on the left-hand side posing 24 hours to get his picture taken. Okay, I made that up on the spot. That's good. One of his big inventions, actually, in order to produce quality sparkling wine, is try to get to keep the CO2, just the carbon dioxide in the bottle. And a few fellow monks that were passing through the region actually had a certain type of cork that they used to close their water bottles on the way. And it had a similar shape as the cork that we know now. And so he actually used that to close the bottles. Amazing, which meant less CO2 was actually getting out of the bottle, so more bubbles were maintained in the bottle itself, and people liked it even more. The problem is, the cork was amazing. It was not popping out. It was withstanding the pressures fantastically. The thing it didn't have taken into consideration back then is that the bottle didn't. And so following the years of the introduction of the cork, bottles were shipped around and they were stored in cellars, etc. And estimates today say that between 50 and 60% of all bottles produced from that time on were never consumed because they exploded. So actually, if you were to buy or to pick up a cellar for your master, or you were buying bottles of wine, you were wearing a mask similar to this, because it's very likely one of them would explode in your face. And at this stage, let's go back to Britain. Keep that bottle in mind now. Chapter 3, British Ingenuity. So about 10 years before Dom Perignon started as a cellar master, I mentioned before, bubbly sparkling wine had already been a thing in England, right? And actually this gentleman, Christopher Merritt, submitted a paper with the title, and I'm slightly paraphrasing it because I don't remember the title, Optimizing the alcohol content and the bubble content of a wine. That's not exactly the title, but that's what he did. The idea really was to, after juice has been pressed and the wine has been produced completely, so the fermentation has been completely stopped, that man advocated to add sugar to increase the alcohol level and also to have a little bit of bubbles in a bottle. And this is where Charles II kicks in, and he loved that stuff. Now, he arguably was on the same thing of starting sparkling wine production, not only the Frenchies. Now, the only thing is, one thing that they had in common with the French is the exploding bottles. So also the bottles that were produced by him, or by producers that followed his recipes, were exploding in the cellars because of the high pressure. And not that he started it, but another unfortunate or fortunate event led to the solution. And this was actually spinned off by Admiral Sir Robert Mansell. So there are a lot of names now today. I'm happy I don't need to remember them. So he was responsible for the shipbuilding industry in England. And he has been in competition with the glass blowing industry. Both of them needed a lot of wood. And he was, because of the amount of glass bottles that had been produced or starting to be produced at that time, he was just very afraid that he wouldn't get high quality woods for his ships. And so he went to King James I and cried about it. And as a result, King James I declared that no more wood should be used as a source of heat to be burned for glass production. So all the glass producers, they need to switch to an alternative. What would that be? Coal, yeah. Coal reaches high temperatures, and with this changes the integrity of the glass, makes it darker, but it also makes it stronger. And here we have the solution to the problem. And obviously they had nothing to do with either Dom Perignon or this guy here before, but they were definitely both responsible for technological advancement in champagne process. So I'll leave it to you whether or not the French have invented sparkling wine or champagne, or the British. But what is true, though, is that champagne or the French, they excelled in terms of marketing and actually continuing the process from there on. So Dom Perignon continued for more than 47 years, to be the cellar master and developing or optimizing the entire process of champagne making, including fining processes, etc. And here you can see a statue of him actually at now what's today Moët Chandon, the biggest champagne producing house in the world, and me. Now, from that history part, let's dive into the physics of sparkling wine. And here first a question to the audience and my students. How many bubbles are formed on average in one glass of champagne that you buy? Any guesses? Who thinks 1,000? Hands up. Okay, 10,000. Okay, 100,000. 1 million? Who thinks it's more than 1 million? Okay, you're good. We're talking about 11 million bubbles. It's a lot, isn't it? Yeah. This corresponds, by the way, to about 0.7 liter of CO2. So, in a closed bottle of wine, closed bottle of champagne or a sparkling wine that has been done similarly to champagne, you have about 12 grams per liter of CO2 dissolved. Now, when you open that bottle or when you pour it in a glass, a new equilibrium of the gas inside the liquid wants to be established with the outside of the liquid, right? So CO2 wants to escape. And it does it in two ways. One, just simply through evaporation of the surface, and second, through those bubbles. And the ratio is slightly 80 to 20. So 20% of all the gas that is dissolved is via bubbles. Now, bubbles don't just pop into existence. There needs to be something happening. Now, who of you have ever blown up balloons? Right? The first bit is hard, right? It takes a while, it takes a bit of effort to get through the first couple of half a liter or something like that, and then it's quite easy to blow it up, right? Similar thing with the bubbles in champagne. We need, in order for bubbles to come into existence, they need to overcome van der Waals forces. So the forces that are pretty much surrounding and driven by the liquid around the gas. And for this to happen, we need little gas pockets that are in your glass or that are in a bottle, for example. And these little air pockets are derived by fibers, dust. Little tiny bits and pieces that are just flying everywhere, house a little bit of oxygen that are then trapped in a bottle or wherever in your glass that you're pouring in. As soon as this bubble is surrounded by the liquid that contains your CO2, CO2 is actually diverting into that pocket, again as an equilibrium exchange. And that little pocket there grows bigger and bigger and bigger because more CO2 is diffusing from the liquid into that pre-existing pocket, growing in size, and once it reaches a critical size, it just pops from that position. I have actually a laser pointer here. Voila. Detaches and starts to rise to the surface. Now, in a glass, this can happen obviously on various different spots, because none of the glasses that we're using are completely clean, so there will be at least 5, 6, or 100 of those cellulose fibers sitting around, and they are also of different sizes. So all of those bubbles, they will be pretty much coming to the surface at different rates and in different bubble sizes as well. And size actually matters here. So as the bubble is rising from the bottom of the glass to the top, it's getting bigger and bigger. Why? Because it's always surrounded by a liquid that contains a high concentration of CO2. So more CO2 is actually getting into the bubble. But it is not happening without any resistance. In water, yes, but in beer or in a sparkling wine, we have other compounds swimming around. So, for example, proteins or monoproteins that are particularly important for sparkling wine and released with bottle aging on the lees. And these monoproteins, they stick to the bubble and cause a little bit of drag. And the more of these monoproteins you have, the slower the bubbles would rise to the surface. And this is a sign of quality as well. In terms of wine, or sparkling wine. Taken away. Another force, another effect that's important, or that is actually driving the bubble from the top to from the bottom to the top, is which force? What is the force that's driving the bubbles up to the surface? Sorry? And that's driven by? Gravity. There we go. One of my favorite John Mayer songs as well. Now, having this in mind, where do you get the tiniest bubbles? Is it on Mars or is it on Jupiter? And why? So on which of those two planets would you expect the bubbles to rise the quickest? On Jupiter or on Mars? Which of those two planets is the smallest? Okay. What does this mean for gravity? It has... Okay, and now, back to my question. Where do you get the tiniest bubbles? Who is for Jupiter? Hands up. Who is for Mars? Okay, it's Jupiter, my friends. Indeed, so higher gravity on Jupiter, so you have actually more gravity, so more buoyancy on the bubble, so it will be going up way quicker, which means there's less time for CO2 to get into that bubble while it's going up. So it's tinier and quicker. Now, if we have to translate this now to your behavior of drinking, if you're one of the fortunate people to go with Jeff Bezos to Mars one day, you probably take a six-pack of champagne with you, or two, right? So you want to enjoy it on the planet. What does this actually mean sensorically? Well, the bubbles are responsible to, or are driving the aroma, or what you smell in the end, because CO2 is it carries along volatiles that you later smell. So the more of those bubbles are actually coming up, and the quicker, the more you actually smell once you actually hold your nose up on the top of the glass. The slower the bubbles are rising to the surface, the less you actually smell. And you might need a different glass for that. You want to have something that has a bit more body, that traps a little bit more air, something like a red wine glass. So this would be my personal recommendation on Mars. Have a red wine glass to capture as much volume of air there and bubbles that are rising to the surface. On Jupiter, drink faster because the bubbles are going to be away very, very quickly and the wine's going to be stale. And with this, I would like to leave you with two quotes of very famous champagne drinkers. Two with different life philosophies, I guess. Remember, gentlemen, it's not just France we are fighting for, it's champagne. And he famously drank a bottle of champagne a day, along whiskey, etc. And Coco Chanel on the right-hand side. I only drink champagne on two occasions, when I'm in love and when I'm not. And I count to these ones probably as well. So with this said, thank you very much for having me here. Drink champagne, but also don't forget to drink Riesling. This is probably the second best to champagne, or equally as good as champagne. Try it out. And yeah, thanks for inviting me. And I'm happy to receive any questions, not about history maybe too much, but about winemaking and champagne production. Please let me know. Thank you. Yeah.
For the production of champagne, do they use wild yeast, or do they use specified, or do they sanitize it and use specific yeast?
Amazing question, yes. Moet Chandon, absolutely, they use industrial yeast, cultivated Saccharomyces yeast, and they have actually their own program, so they have their own selection of yeasts that they are using and drying and actually producing their champagne off, just for consistency reasons. So they're producing millions of bottles, they need to taste the same all around the world, so that's a different story. But there are a lot of grower champagne producers, talking about a couple of hectares, they experiment with wild fermentation, yes. Less so in the second fermentation in the bottle, more in the first fermentation. But it also happens that people just, they stop the first, or once the first fermentation is stopped, they rack it roughly, add more sugar, maybe some yeast, some nutrients, and then close it up again for a second fermentation. It happens. Yeah. It's a bit risky though.
Is it fair to say then you'd be happier to be served champagne in a dirty? Is it fair to say then you'd be happier to be served champagne in a dirtier glass? With like if the aroma gets carried up on the bowls of CO2.
No. I think at the conditions that we are used to drink champagne under, it's absolutely enough to have a clean glass, to request a clean glass. Don't pay $25 for a glass of champagne if the glass is dirty. No. Good. First one.
I think he was supposed
First one.
I think he was supposed to.
Hypothetically, if I get a trip to Mars with Jeff Bezos, would Earth's current champagne bottles be sufficient to not explode?
That's a really good question. I mean, the current champagne bottles that you buy, they need to withstand a pressure of 50 bar. And the pressure that you get out of a bottle is around, at 20 degrees Celsius, is about between 6 and 7 bars of those champagnes. So you have a little bit of wiggle room. but I don't know the numbers. But you can definitely, you can leave the champagne bottle in the sun for ages, nothing will happen. So I'm confident it can be getting close.
Well, not that it should happen. Basically,
Yeah.
well, not that it should happen. Basically, I have to store leftover champagne for the next day.
Sorry, come again?
Having an open bottle and leaving it to the next day, where's the best way to do it? Not that it should happen ever. Just finish.
Now, in my experience, if you keep it in the fridge, the next day will be still enjoyable usually. Yeah, and the spoon trick doesn't work.